In this example, we will try to find the Fourier series of the following waveform, right? But first of all, the waveform must be a periodic waveform. So how we can determine whether the waveform is a periodic or not? Simply by looking at the shape of the waveform. So it's first start from here, right? It goes up to 1. Let's go straight to 1 second, go down, and then straight here, and then go back up again. So here we can see that it is a repetitive or periodic in this shape. So this is one period, okay, and it repeats itself at a positive second, at positive time, and even before that, right? So that is a periodic function. Now once we have determined that this is a periodic waveform, then we can work out to find its Fourier series. Now basically the answer that we want is this equation, a naught plus sum of an cos and omega naught t plus bn sine and omega naught t, right? And from 1 to infinity. So this is the answer that we want to get. So this is the Fourier series of the waveform. However, we have to find the coefficients, the Fourier coefficient, which is the en, which is an bn. So we have to find out all these values, omega naught, bn, n, and so on, to get the final equation. Okay, so what is the equation for a0? a0 is 1 over t, the period, integration of ft dt, integration from 0 to t. So this is the general equation for a0 or a naught. Right, so what is t? One period is t, so t is in this case from 0 to 2. Right, so here we can complete the equation for a0, right? 2 equation from 0 to, now this one, hang on, we have to look at the waveform first. So ft is the function of the waveform. So we have the waveform here, right? So what is ft? Ft is this, and ft is this. So ft is actually 1 and 0. 1 for 0 to 1, 0 to 1, and then 0 for from 1 to 2. Okay, so this is the ft, right? So it's from 0 to 1 for 1 dt plus 1 to 2, 0 dt. So that is the way how to write down the a0. But however, since this is 0, you can completely disregard that. So it's just basically 0 to 1, 1 dt, and then we can get the value 1 over 2 t to 0, 1 over 2, 1 minus 0, 1 over 2. So that is for a0. Okay, next we can try to find an and bn. Let's start with an first. What is the equation for an? An is 2 over t integration of ft cos n omega naught dt, sorry, omega naught t dt. So this is the general equation to get the an. We can try to complete this equation. So t is 2 integration of, so in this case 1, which is ft is 1, which is from 0 to 1. So from 0 to 1, ft cos n omega naught t dt, and in this case omega naught is 2 pi f, or 2 pi over t, or 2 pi over 2, which is pi. So we can simply replace omega naught with pi. So it's cos n pi t dt. So an is integration of 0 to 1 cos n pi t dt. Alright, so integration of cos function, you can simply refer to this formula, dt, so it's equal to 1 over a sine at. Right, so we have a here, and a here. Right, so in this case this is our a, so that is 1 over n pi sine n pi t, right, from 1 to 0. Alright, so that is 1 over n pi sine n pi 1 minus sine n pi 0. So we have here sine n pi is actually equals to 0, right? Can actually refer to the sine waveform. So this is 2 pi, this is pi, this is 1. So for sine 2 pi, that is 0. So for whatever value, if n is 1, is sine pi, sine 2 pi, sine 3 pi, so whatever value of n, it will always be 0, right? So we get 0 here minus sine 0, sorry, sine 0 is 0. Okay, so we get 0 here for an. So next is we want to find bn. So bn, the equation is 2 over t integration of ft sine n omega naught t dt from 0 to t. So this is the equation, and again the function, the equation for integration sign at dt, right, will give us 1 over a, negative 1 over a cos at. So we have a here, and a here. In this case, this is our a, right? Dn is 2 over 2 integration of 0 to 1. Ft is 1 sine n pi t dt. So we get so this is our a, this is 1, so we get negative 1 over a, yeah, negative 1 over a is n pi cos n pi integration from 0 to 1. Okay, so cos n pi 1 minus cos n pi 0. Okay, so for cos n pi, this will give us negative 1 to the power of n, while cos n pi 0 will give us 1, right? Cos 0 will give us 1. Now, how to determine this value? So we have to draw the cos waveform. F1. This is pi, this is 2 pi, this is 0. So if n is 1, cos n pi, right, cos 1 pi will give us negative 1, cos 2 pi will give us positive 1, cos 3 pi, this is 3 pi, will give us negative 1. So it is like this, negative, positive, and negative. So here we can simplify all this by a negative value, right? If it's an odd number, it will always give negative, right? Odd number, it will give negative 1, while if n is even number, 2, 4, it will give us positive value, right? For example, if this positive number, even number 2, will give us plus 1, right? So this is the simpler terms of this cos n pi, right? So here we can simply reduces the equation to as such. So this is our Bn, and then we can simply we further simplifies this 1 minus 1 n pi, right? And actually if we continue to look at this equation, we can actually further simplify it, right? So let's look at what happens if n is an even number, right? So if n is even, so n is 1, n is even, so we get that to be positive number, right? That is 0. If and is what? Bn is 2 over n pi, right? Or like this, right? Get 2 over n pi. This is our Bn. Now let's go back to the main equation of Fourier series. Ft of a0 plus function of an cos n omega naught t plus bn sine n omega naught t and from 1 to infinity. Right. So what is our an? So we have calculated that our an is 1 over 2, right? And what is our an? Our an is 0, so completely 0 here. So what is our bn? Our bn is actually depends on the n value. If it's even, it's 0. If it's odd, it's a 2 over n pi, right? So we can just simply use the odd value and odd, right? And so here 2 over n pi sine n pi t, right? And further simplifies this is we'll get here 2 pi. Okay, so n we have to keep it inside the bracket, right? But the rest 2 pi, 2 over pi, we can take it outside. So here n equals 1 if it's odd only, alright, sine n pi t over n. Alright, and that is our Fourier series of the waveform.